Hi everyone, we're going to be constructing a calibration curve for the data we found with Lab 2 Week 1. And you can see on your screen we have everything we need to do that. Here in column B is our concentration of nickel, and in column C is the absorbance of our nickel in nanometers. So nickel is going to be the x-axis, absorbance is going to be the y-axis. I also calculated standard deviations and a 95% confidence interval for 2 degrees of freedom. Below that you can see our least squares analysis, where it gives us our slope, our b, our y-intercept, and the r-square value. Below that is all of the data that we need to calculate uncertainty of x there. So in order to construct the graph, I found it easiest during my many trials and errors to select the x-axis, which is concentration nickel, and the y-axis, nickel, x, y-axis, there. So go to Insert, Charts, and Scatter. This is our scatter plot graph. Bring it down so we can see a little better. And so here's a really basic graph. I'm going to choose style number 5 because the dots are small and later you'll be able to see the error bars. I'm running Windows or Microsoft Office 2013, so the steps from here on out might be slightly different from what you see. So we'll go from there. Here is the chart elements, everything we need for our chart. So we have the axes labeled, of course. I'm going to title the axes. I'm going to leave the chart title. I'm going to remove the grid lines so later we can actually see the error bars. And I'm going to add a trend line. I'm going to select that. Select this arrow. Goes to more options. And from here you can display the equation and the r-square value. Move that down so we can read it. And so you can see the trend line gives us y equals 7.3359, which is our slope found here, plus 0.0092, our y-intercept, or b, which is found there. So let's label our axes. So this is the concentrated nickel in moles per liter. And our mean absorbances. Oops. In nanometers. And so I'm going to just label this chart so it says exactly what I just said. So the concentration of nickel, moles per liter or molar, versus mean absorbance in nanometers. So there's the first part of the graph. Now to add the error bars. I know a lot of us had trouble putting the error bars on our graphs. And so let's just walk through that. So I'm going to select error bars, and here you can see it gives us a horizontal and vertical error bar. And so I'm going to select this arrow here and more options. Right off the bat it gives us horizontal error bars. We don't need that. So I'm going to customize that, specify the values so that they are 0 and essentially go away. Which leaves us the vertical error bars, which are not actually our error yet. So for the error bar options, there's this drop down menu here. I'm going to select the series absorbance Y error bars there. And so we want the direction to go both ways. We want them to be capped. and we should customize what we want for our error bars. So I'm going to select custom, specify the value, and here you can either do standard deviation or 95% confidence interval. And so let's do the standard deviations first. I'm going to select the first value and the last value for the positive, and I'm going to do the same for the negative. Okay. And there they are. Very small. But they are there. We can remove the trend line temporarily to see that they actually are there. And they are. And so let's add our equation in our square value again. And so the same can be done to use the confidence intervals for our error bars. So I'm going to select more options. It gives us that first. Select Y. Specify the values, and instead of here, we're going to select the 95% column. And there they are. So that is how to construct a calibration curve for the data we found in Lab 2, Week 1.